About 6 years ago, I took a look at this cheap 1U server from AliExpress and set it up as my home firewall. Well, it's now 6 years later and technology has progressed quite a bit. So I thought, well, what about taking a look at these again and seeing what you can get for your money nowadays? So let's take a look at what I've got. And here we have what I've bought. So when I took a look around, it turned out that actually a lot of the devices that I'd seen previously 6 years ago were still available. There's still so many of these devices using CPUs that were even quite old 6 years ago. So I kind of had set myself some criteria of what I wanted to get, rather than just buying the cheapest one available, because I'd be getting something basically identical to what I already had. So what I wanted was something that had 10 gigabit networking on board, and that used a relatively current CPU. And that's because a lot of these devices generally use older parts. I think that's how they make them cheap. They're either using potentially recycled parts on some of them, or parts that are end of life and there's surplus stock. So there's lots of devices out there with things like Intel Atom D2500s or Celeron J1900s, or even sort of just early sort of Ivy Bridge laptop chips, like what, the i5 3420M, I can't remember the model numbers from back then, but those kind of early 2010s chips. A lot of devices use that. You do then get some with 10 gig networking on board, but what they're doing for that is they're using a relatively old CPU and then just chucking in an onboard NIC soldered to the main motherboard, and that's another sort of relatively old Intel NIC, and it's 10 gig, but you've got a very old 10 gig NIC connected to a very old CPU. It's not going to be great. So that's when I came across this one here, because this actually uses relatively current parts. In fact, as far as I can tell, all the parts in this are current generation. There's nothing end of life or, surplus parts in this. All the parts in this are currently made. It's very much a current generation machine. So obviously with AliExpress, it's really hard to name these things, never have proper model numbers, so I've put links in the description. But this is from a brand called BKHD, who seem to make a lot of these sorts of things. And this particular model here has the Intel Atom C3558 CPU. And that's what really piqued my interest, because that is still a current generation Intel CPU. It was launched back in 2017, but Intel haven't really changed the Atom lineup, so you can still go out and buy a brand new server for significantly more than this with that CPU. Back when the Atom lineup first came out, it was targeting things like netbooks and nettops and small form factor desktops. However, since then, Intel seems to have killed off that kind of line of Atoms in favour of much just lower power general Intel Core CPUs, and instead they've moved the Atom line to be more focused on things like servers and network appliances like this. And that's what the C series was designed for this kind of application. So rather than all these other devices with the D series Atoms and the J series Celerons, this has an actual server CPU designed for this type of application. It's a quad-core chip, but this device here is also available with the Atom C3758 CPU for about £80 more, and that's 8 cores. And what's really good with this series of CPU is that because it's designed for this kind of application, it's a system on chip with a lot of things built in, including the 10 gig networking. So with this device here, you've not got some sort of super outdated Intel 10 gig network chips sort of bodged into the motherboard on a PCI Express line. These 10 gig network ports are running directly off of the Atom SoC. These here are using external PCI Express NICs, we'll take a look at those later, but the actual 10 gig networking, which is the bit that's going to be much more power hungry, much more likely to go wrong, these SFP modules are basically wired directly into the Atom SoC. There's a bunch of different versions on the product page apart from the CPUs, namely in terms of RAM and included storage. So the device I went for here was the base model, which has 8 gigs of RAM and 8 gigabytes of eMMC storage. The other devices offer, I think, up to 256 gigabyte of M.2 SSD, I think up to 16 gigs of RAM. But it's interesting to see that this has 8 gigabytes of eMMC, so it'll be interesting to see how that's kind of built inside here. So yeah, I just went for the base model because realistically, I'm going to be running PFSense on this. I don't need more than 8 gigabytes of storage. And if I did, I've got plenty of M.2 SSDs I can stick in here. I don't need to buy another one. And as for the price, this was only £360. Of course, depending where you're buying this to, obviously it'll be a different currency, but also you might have different tax and shipping costs. I did have to pay import tax on this, so it did cost probably closer to £450. But for a modern CPU in a machine with built-in 10 gig networking, that is really cheap. Now obviously you can't really compare something like this to like a high-end Supermicro in terms of build quality and reliability and just knowing that you're getting a good machine. But to get the equivalent of something like this from Supermicro, you're probably looking at well over £800, you know, £900, you're looking at a lot more money. So especially for kind of home use or lab use, this is a really good deal. So now one thing I would say quickly before we get into this, just as a sort of warning as well, is if you're looking at devices like this and you're looking at C-series Atoms, avoid the C2000 series. This is a C3000, it's perfectly fine, nothing wrong with it. However, the C2000 had a very known bug, and it was due to some sort of LPC bus clock line or something, and essentially what would happen is over time that clock line would fail, and that was the clock line used to power the BIOS chip, or feed the BIOS chip. So what would happen is the machine would run perfectly fine until it rebooted, and then it would just be dead. And this affected a huge number of devices. A bunch of Atom servers were affected, a bunch of Cisco switches were affected, a bunch of Synology NASes were affected. It was a huge deal. Now it turns out that it's been possible to actually use those CPUs by reworking the motherboard, but if you're buying a sort of off-brand device like this, I wouldn't risk buying a C2000 series Atom, just because if they've not put that workaround into the motherboard, you could end up having it die when it reboots. But the C3000 has none of this issue, so it's perfectly fine. So that's what we have here. So yeah, now let's take a look at it. So first of all, we've got this box of accessories. I've also taken out the main box. We'll take a look at the accessories box before we get into it first. Nothing that exciting in here. So you get a 4-pin sort of floppy drive power connector to SATA adapter. This is similar to what I had with my other one. Essentially, if you want to put an external or separate hard drive in this, you plug this end into the motherboard, this end into your drive, and that powers your drive. I'm not going to use that, but you do get that if you want to put a 3.5 or 2.5 inch drive in here. You also get a SATA cable, again for the same application. You get a power cable. I've got an EU power cable. On the listing, it gave you an option of the power cable you wanted, but I think I just picked the wrong one because I think I'd probably just picked the wrong one. So you will probably get the right power cable for your country. I didn't, but I almost certainly ordered the wrong thing because I was rushing. Then finally, you get some rack ears. So these will mount onto the side there and there to allow you to mount it in a rack. Now, I'm not going to put these on right now because to get the top off this, you would need to remove those. So there's no point putting in 8 screws, only to take 8 screws out to get into it to show the insides, but I'll put those on later. And then finally, you get these screws here, which I don't know what they're for. I suspect that if you're installing a hard drive, you'd probably use these to mount a hard drive in the case. So you get some spare screws for that. So that's what you really get in terms of accessories there. So what we'll now do is take a look at the device. So here we have the device. It's a pretty nice looking thing. It's not too deep, so it's a standard 1U 19-inch form factor, and it's about 260mm deep, so it'll fit in most short depth cabinets. On the front we can see we've got this sort of design here. This is like an extra plate that's almost fixed on over the underlying material. It almost feels metal. It might be, I'm not sure, but it gives a bit more stylish, more stylish look. And on the front we can see all the I/O. So there's a group of LEDs here. There's a power LED, presumably drive activity LED. I'm not sure what the other two are. I think they're to do with the LAN bypass that we'll talk about in a second, but I'm not 100% sure. A serial port, so that's an RJ45 serial port, a pair of USB 2 ports, 6 Gigabit Ethernet ports, and the 2 10GB SFP Plus ports, and then LEDs for each of those. And I mentioned there this has LAN bypass. Now, this is an interesting feature that you get on a lot of these weird sort of network appliances. And essentially what it means is it applies to these 2 network ports here and these 2 network ports here, so the last 4 ports. When the device is powered on, these work as separate network interfaces. But when the device is powered off, these 2 ports are connected together and these 2 ports are connected together. And this is done by a set of relays on the motherboard, so we'll take a look at those inside. The idea behind this is if you're using this in some sort of application where if this device failed, you want the network to keep operating, you could use these interfaces. So you probably wouldn't want to do that for, say, like a firewall or a router or something like that. But if you're, say, using this for like just traffic analysis, you know, you're passing traffic through this and this is analysing the traffic, you could use this to have the traffic going in and out of these 2 ports here. And if the device ever failed, these ports would just be connected together and the traffic would continue to pass with this device offline. It's not something I'm really going to use here, but it is a feature that it has. However, I've not been able to find how you control this. You know, if there's a way to turn it off or a way to configure it or a way to switch it on and off from software, I can't seem to find much information on this. I've emailed the manufacturer, but I haven't heard back yet. So if I do hear back, I'll put a bit of text up on the screen or I'll jump in and demonstrate it or something. But at the time of filming this particular section, I don't know how to configure this, but it's just something to bear in mind. All I would really say is if you do have it and it is enabled and you can't switch it off, just kind of be mindful of what you're plugging into these ports, because if you had devices plugged into these 2 ports here, if this were to turn off, these two ports be connected together. So just be careful. Worst case scenario, you just need to use these as 4 ports. So you'd use these two, this one, and leave these two unoccupied, and it would work completely fine. But just bear in mind, if you say you had these two connected to something, they'd be shorted together, and either that could bypass your firewall or cause some sort of weird loop on some switching or something like that. So that's just something to bear in mind. The other thing that's worth mentioning is the front I/O on this is actually labelled in a fairly sensible way, which is quite rare on these kinds of devices. A lot of these devices, they'll either try and label them WAN and LAN, which is just silly because obviously you're installing an operating system on this that you can customize. Your configuration of WAN and LAN ports is probably completely different to what they've printed on the front. So this obviously doesn't do that, which is good. But the other good thing is they've started numbering the ports from 0, which is also sensible. Because on my old device, they were all labelled LAN 1 through 6, which is just silly because under the operating system, they're going to be numbered from 0 to 5, not 1 to 6, and they're not WAN ports. So in this, the Ethernet, the RJ45 ports are labelled ETH0 through ETH5, and the SFP Plus ports are labelled SFP0 and SFP1. And this is pretty sensible. Now, of course, I'll be running BSD on this, so these won't be showing up as ETH, they'll be showing up as either like IGB or IGC0 and stuff like that. And these won't show up as SFP, they'll show up as, I think, XG or something. But at least the numbering will be vaguely sensible. They'll match up in a reasonably understandable way, which is good. It's much better than having them numbered from 1 or labelled WAN and LAN. So it's nice to see sort of fairly sensible port labelling on this. But yeah, that's the front of it there. So now let's take a look around the back. So around the back, there's not really that much to see. All you have is a pair of 40mm fans, we'll take a look at in a second, an IEC power inlet, a fuse, a power switch, and that's it. Apart from that, all you get is a label here that says, caution, rise of electric shock, DC not open. Yes, but nothing else on the back. And this is where you might notice something a bit interesting that's missing from this. There's no video output, and it was something that kind of threw me when I first got it. Not that it confused me, it was just like, oh yeah, there's no video output, as I was sitting holding a VGA cable trying to plug it in. That's because with the C series of Atoms, they don't have built-in video because they're designed for server and network appliance applications. Generally, if you're buying a one-use server like this from a bigger manufacturer like Supermicro, it'll have some sort of onboard management controller. And with those, you generally have a single chip that acts as a management controller and also acts as a video card, and that's connected to the CPU over PCI Express. Because this doesn't have any sort of out-of-band management, that means that there's no video card in this, so you can't actually plug a monitor into this. Now, when you see inside there is a PCI Express slot you could use to potentially plug a graphics card in if you absolutely had to, just to set it up at least. However, out of the box, it's set up to use the COM port as a serial port. So all you do is just need to set it up as using it over a serial console rather than a monitor. So plug a serial cable into that, plug it in the computer, use some serial terminal application, and you can easily get it set up. So we'll take a look at that in this video. But yeah, that's a look at the hardware. So what we'll now do before we install an OS is we'll quickly pop it open, see what's inside, and then we'll install PFSense on this. And now here we are inside the device. And it's basically what you'd expect. It's very similar to my old one. All you have is this one motherboard here that contains absolutely everything, a couple of fans, and a standard open frame power supply. But there's a few things to take note of. So the power supply here is made by Meanwell, and it's an LRS 50-12, so that's a presumably 50 watt, 12 volt power supply. And that's really good to see, because obviously with these sorts of things, it's a bit of a cheap sort of off-brand device. The last thing you want is them to have cheaped out and put a really dodgy power supply in it. However, Meanwell are a well-known brand. Obviously they don't really make PC desktop power supplies, but they make lots of these open frame power supplies, external power bricks, all that sort of stuff. And because of the way this motherboard is designed, all it needs is 12 volts, so this is a perfectly good motherboard or power supply to power it. However, the only thing to bear in mind with this is because it's unlike a standard PC where all the sort of mains electrical stuff is inside an enclosed power supply. In this case, some of it's out in the open. Now, there's nothing really wrong with that. Like, it's not dangerous. It's not any more dangerous than, say, taking apart a set-top box or a DVD player or a games console or something like that. However, it's something that's very different to a normal PC. Now, I've checked and the main chassis is grounded to earth, so that's completely fine. But it's just something to bear in mind because there are live terminals around here. And let's just say I'm an idiot and I blew my finger off. Because, as you can see on the back, it says rise of electric shock, not risk of electric shock. So I clearly didn't know that there was a risk of electric shock and managed to shock myself. Yeah, it actually wasn't the sticker's fault, it was me being a complete idiot. But essentially, what I was doing, and you can kind of see where this was going, is I was trying to work out investigate the fan noise. So I was like, right, what I'll do is I'll power it up, turn it on, I'll unplug the fans and see where what fans make what noise, you know. It's fairly standard stuff. So I'm like, right, I just need to plug it in. So I went away and got my IEC power connector that I will unplug from the wall so I don't do it again. And I was like, oh, I just need to plug it in the back. So I was just casually plugging that in there. And of course, you're pushing it in and it's sliding across the table. So a sensible person would grab the front of the machine and plug the power cable in because they're smart. But what I did, because I'm a complete idiot, is I had the top off the machine and did that. Now, if you look on the back of this, there are some live terminals. So thankfully, because of the invention of RCDs, I didn't die. I just lost the power. But be careful because there is live mains around here. Now, again, that's not a sort of something they've done that's really bad and really dodgy and they should never have done. It shouldn't be built this way. It's just something to bear in mind that there's live mains on the back of this connector here and live terminals here. Don't go touching them. Because it's just very easy to do. When you're used to working inside PCs, not appliances with live mains exposed, you're just used to being able to touch everything when it's on and that's fine. But in this case, you can't. But other than that, that's all fine. And it's nice to see a nice branded Meanwell power supply and not some sort of weird off-brand thing. And this just connects into the motherboard here over what basically looks like a 4-pin EPS connector, I presume. That just plugs in there. And as you can see with this motherboard, it's designed for rack mount cases and desktop cases because on the back of the board here, you can see you've got a couple of switches for power and reset, some LEDs that replicate what's on the front, and a DC barrel jack with a screw thread. So you could kind of have that sticking at the back of a desktop case and have an external power supply if you wanted. The only other thing I've noticed with this is that the motherboard is a little bit loose out of the box. Not in the sense that it's unfixable, it's just that these two screws at the back here have jogged a little bit loose, so the motherboard rattles a tiny little bit. So all I need to do is just tighten those up and that'll basically be completely fine. So tighten that screw there, and it's completely fine. Like that's literally fixed it. And thankfully that screw at the front there seems fine. I'll just check it. Yeah, that screw there is fine, and that one there I can't really get to, but again, it feels fine. These two, you can actually feel them rattling. So that's fine. But what I would say is when you get one of these, just check all the screws are tight. Especially these mains ones on the power supply, when it's disconnected from the mains, obviously. Just nip these up and just check they're definitely tight, because you don't want to find any of these sort of coming loose in transit, and you power this up with a loose connection in it, because that could be quite bad. So just give each of these terminals a little tighten. They all seem pretty tight, but I just wanted to check them. But yeah, other than those loose screws, it's completely fine. So now we've done that, let's see what else we got on this motherboard. So now here we have the motherboard. And the first thing you might notice is down the front here, there's all these weird components here. These are the relays used for the bypass. So each of the wires coming out of those 4 ports goes through those relays and they switch it, so they're either switched through to the network cards or switched through to link the ports together. So that's what those do there. Then behind those relays, you can see we have these chips here. And these are the NICs that provide those gigabit ports. And these are Intel i225V network chips. Now, interestingly, those are apparently 2.5 gig network chips, but all the ports on this only link at gigabit, and they're only advertised as gigabit, so I don't know why. I don't know if why they're running these at only gigabit. Are they maybe binned separately so they're not able to do 2.5 gig, or is it just the hardware here doesn't support 2.5 gig, the bypass wouldn't work with that? I don't know. But yeah, even though they are on paper 2.5 gig chips, they are only operating at gigabit in this device here. However, I've checked, and these are the revision 3 of these chips. I've seen a bunch of stuff online with people having problems with this model of network chip, various bugs, but apparently they were all resolved in revision 3 of the chip, so these chips shouldn't have that sort of issue. Next up, we can see we have the various expansion slots. So we have 3 M.2 slots. This one here is labelled as, I've lost the label, M.2 WLAN. So this will be used for M.2 wireless cards. Here we have one for SSDs, which is labelled M.2 SATA, SSD SATA M.2. Now, because it says SATA there, I suspect this might only be wired for SATA, not NVMe drives. So if you were wanting to use an M.2 drive in this, you just need to make sure you use a SATA one. Realistically, in an application like this, you probably don't really need NVMe storage, so just make sure you use a SATA one. Might work with NVMe, but I've not really tried it, so I'll stick with SATA. Finally, you have this M.2 slot here, which is labelled as 5G. And this would be if you had a mobile data dongle, mobile data card. So you'd put your M.2 mobile data card in there, and then underneath here, there's a SIM card slot, so you could put a SIM card in. So you could easily add in Wi-Fi, you could add in mobile data, or you could add in a SATA SSD. So it's nice to have all those M.2 slots. And I suppose realistically these will just be PCI Express. You could probably stick other cards in here as well. Finally, around this area here, you can see you've got these two SATA ports. So these are if you want to connect a 3.5 inch or 2.5 inch hard drive. So over here, you can see there's this big area to mount a drive to. So you take this out, screw through the bottom into your drive, and you can either mount two 2.5 inch drives or one 3.5 inch drive, and you connect that into these ports here. So you'd have a SATA cable that goes from here over to your drive, and then for power, you'd use this cable that came in the box, and you'd plug one end of it into one of these headers there. These aren't fan headers, so don't get them confused. Plug that in there, and this other end, plug into your drive. And this cable is long enough to reach over here, so that would be fine. And then finally, in addition to those M.2 slots, there's also this slot over here that appears to be a PCI Express slot. I haven't tested it, and it does just say GFPE1, but I did see a thing online with someone with a graphics card in that, so that might be a PCI Express slot, but don't quote me on that. Of course, you're not really going to have a card permanently in there, but it means if you needed to install an OS that wouldn't install over the serial port, you could possibly put a video card in there and use that to at least do the install. Then over here, we can see we have the RAM. So there's one RAM stick installed. I suppose dual channel would be nice, but really in a firewall like this, you don't need that. So this should be an 8GB stick. And as you can see, yep, it is. It's obviously a very generic brand. Don't know what that is, but it's an 8GB stick of DDR4 RAM. Interesting to see it's also a 3200 MHz stick. Although as far as I'm aware, the CPU can only go up to 2400 MHz. But yeah, that's the RAM they've included there. So that'll do. Probably not the fanciest or best RAM in the world, but it'll work. So that's our DDR4 RAM that can go in there. And of course, you could easily upgrade that if you wanted to. And then one thing you'll notice here is that obviously it's got 8GB of eMMC storage, but there's no card. So the eMMC isn't on an M.2 card or anything. I was wondering if it would be like that and they were just calling it eMMC rather than an SSD for the low capacity option. But no. If you look down here, we can see a chip. And that chip has a part number of KLM HG1 GETF-B041. And that's an 8GB Samsung eMMC chip. So that's down there. I think it's a relatively modern part. I think it's eMMC 5.1, so it's a fairly recent standard. And that's it down there on the motherboard. So it means that when I'm installing PFSense on this, I can install it directly to that eMMC chip on the motherboard, rather than needing to put in external SSDs. Because that's always the thing when you're trying to build a firewall, you don't need much storage, but the smallest SSDs you can get nowadays are probably about 128 gigs. So you have to buy an SSD that's much bigger than you need for no real reason. So it's quite nice with this, you can install just that eMMC chip, which will probably be lower power consumption as well than having a separate SSD. Of course, if you want to do some sort of like packet logging and traffic analysis, that might not be big enough. But what this also means is you could put an SSD in here, use that for all the logging and log analysis type stuff, and keep the operating system separate on the onboard SSD. So your logs that can't fill the drive up and cause issues with the main OS, they're on separate drives. So that's quite nice to have. So yeah, it's quite nice having that eMMC storage there. But yeah, I think that's really it for the motherboard. Obviously over here you've got the M.2 cages, but you can see there's no other controllers associated with that because these are just connected directly into the Atom SoC, so there's no additional network controllers. These are literally wired directly into this, which is quite good. And then around the motherboard you'll see an absolute ton of headers. I don't know what they all are. Some of them are fairly clearly labelled, like there's one here that's labelled USB for that white one, but I'd never seen a USB header that looks like that before. Some of these over here, like this one labelled LED, so that's presumably a breakout for all the motherboard's LEDs to be installed separately. I think there's some serial port headers on here. There's a bunch of different headers. Some of them are labelled, but you may struggle to find documentation on these because obviously there isn't a manual for this, so you can maybe figure some of them out, but there's a lot of headers on these. But that's what you kind of get with these types of devices. Is they're built for very embedded applications where the manufacturer would know exactly what the pins are, but if you're buying it kind of in a particular appliance, you're not going to get this sort of service manual for the motherboard itself. But it does mean if you did want to mod this, there's quite a lot of potential if you could figure out what these headers did. There's a lot of options on these. And that's why I really like playing with these devices, is they're a lot more interesting than just buying a boring off-the-shelf ITX motherboard. These have a lot of very weird proprietary things that were clearly designed for a very specific application like this bypass, that you would just never see in a normal motherboard. Finally, we have the fans. So as you can see here, we've got one 50mm fan on top of the CPU heatsink, and then two 40mm fans at the rear of the case. Now these are quite a nice way they're mounted, where the fans are actually mounted to a plate inside the case, and that plate is held in with two screws. So I've taken those screws out, and that means you can then pull that out, and the whole sort of fan assembly comes out, revealing the actual screws holding the fans in. So if we pull this out and unplug it, we can see we have two basic 40mm fans wired into one 3-pin connector. So there's no speed monitoring on these fans. And And if you look at the back, you can see these are not the best fans really, and it's what you'd expect. It's a cheap device, they're going to cheap out on things like the fans. I'd rather they cheaped out on the fans rather than the power supply. So as you can see there, it's a the brand is brushless DC fan. It's a model 4020S, which just means it's a 40mm fan that's 20mm thick, so that's not really helpful. It's 12 volts, it's made in China, and I think that logo is actually the logo of a fan manufacturer, but it's so generic it just looks like a fan. I don't have high expectations for these fans. I suspect they're probably basic sleeve bearing fans, they're probably not good quality ball bearing ones. So personally I'm going to replace these. The noise isn't actually too bad. They're probably a bit too loud to have sitting next to you, but if it's in like a comms cabinet, you're not going to hear it through the wall. So they're not too loud, and realistically this doesn't need that much cooling. But I don't really trust the long-term reliability of these fans, and I've already got some good replacement fans, so I'll replace these later in the video. But it has these fans. We'll hear the noise of this when we first turn it on with these fans, so I'll keep these in for now. But if you're looking to do some sort of upgrade to this before you put it into service, I'd potentially replace these fans. But they'll do for now, so we'll get these reinstalled. Then next up here, we have the fan that's on the CPU heatsink. So I'll pop this off just to see what it is, just out of interest. But it's just a little 50mm fan screwed to the heatsink. So I'll get these screws out, we'll take it out, and I'll look it up. Okay, so I've removed this fan so we can pull it out and take a look at it. So if we look at that on the bottom there, it's a Ambiond fan. I have never heard of them. And the model number is an AVF5010LB. It's a very basic 50mm fan. I looked it up on AliExpress, on Alibaba. I found a random listing for these fans, and it seems as though the B on the end apparently means ball bearing. So that bodes at least a little bit better. A ball bearing fan should be more reliable than a cheap sleeve bearing fan. So it's possibly not the best fan in the world, but I'm hoping it'll be fine. I'll just leave this on. I'm not going to bother replacing this. It was also pretty quiet in testing, so that's not really a problem. So I'll put that back on there. So it's probably not the best fan, but it is at least apparently ball bearing. But what's good with this is the fan is a standard replaceable fan. So it's 50mm, which is a bit of a weird size. You're not going to get a 50mm Noctua, for example. And I bought some 50mm Silverstone fans before, and they were dreadful. Like, one of them died after a month. But you can go out and get decent 50mm fans from brands like Delta and Sunon and those kinds of things. So if this fan did ever fail, it'd be relatively easy to source a replacement and screw it onto the heatsink. And that's a nice welcome improvement over my previous one of these. Because if we take a look inside my previous firewall, you can see that you have this. Now if you excuse the dust, this ran for many years. But you can see on this, we have this heatsink with this kind of blower style fan integrated into it. And this is obviously going to be a lot harder to replace. I did somewhere see a replacement fan of this kind of style, and there are screws there, but trying to source a replacement for this kind of fan and fit it would probably be an absolute nightmare. And in fact, obviously I ran this machine for many years, as you can see by the dust, and towards the end, this fan did start getting a little bit noisy. You'd occasionally notice, I think if you powered it on from cold, the fan would make a sort of vibrating rumbling noise, and then if you gave the machine a good whack, it would balance out and start working again fine, so I kind of lived like that for a while. But this fan is starting to wear out and get a bit noisy. But obviously on this, it would be quite hard to replace. So it's good on this one that it is a standard 50mm fan, so if this did ever fail, I could easily swap it out for a new one. So that's good to see. So yep, that's fans all now reinstalled there. I'll probably replace these two later in the videos, but I'll get it all set up first and do all that before I replace these fans. But this fan, I'll kind of leave it as is. Another thought I had while reassembling this is the benefit of having the 10GB NICs built into the Atom SoC also means that this fan and heatsink here also cool the 10GB network controller. On the other hand, you'd have a 10GB network controller on the motherboard, and they tend to get quite hot. So you'd either have to have a heatsink on the motherboard that would then need to get enough airflow over it to keep it cool, or you need like an extra fan. Whereas with this, similar to my Intel Xeon D server, because the 10GB NICs are built into the SoC, that can be cooled by a very good CPU cooler, rather than a sort of extra little cooler on the motherboard. So that's really good. But yep, I think that's all there is to see inside. So now let's get this put back together and fire it up. Okay, so now let's fire this thing up. So as I mentioned, obviously there's no onboard video on this, so we need to use a serial console port. So for that, I'm just going to use a standard serial console cable. So this is a RJ45 connector on one end and a DB9 serial connector on the other end. These are quite common. They're often referred to as things like Cisco cables, things like that. They're very common for things like network appliances, firewalls, switches, all that kind of stuff. So these are pretty easy to get. You didn't get one in the box, but jump on Amazon. They don't cost much at all. I don't even know where I got this one from. It probably came with a random thing years ago. But yep, so we're going to plug the RJ45 end into there. And that gives us a standard DB9 serial port. Obviously, my laptop doesn't have a serial port. So what we'll use is a USB to serial converter, just one of these cheap little things. Again, these are very inexpensive. And actually, if you're buying these nowadays, you don't really need to have these two separate devices. You can now buy pretty cheaply a RJ45 to USB console cable, where essentially it's just this, but all integrated into one USB connector. So it would literally be that into your laptop over USB. So you can get one of them if you needed it. But yep, this is what I'll do here. So we've just got the RJ45 port to DB9 connector into a USB serial adapter, which can plug into the laptop's USB port, which is there. And then all we need to do is use some sort of serial console application on the laptop. Under Linux and Mac OS, you could use Minicom. Under Windows, you can use Putty, so we'll just fire up Putty. Like that. And then we're just going to use a serial console, and it's COM4 115-200 baud. So we'll zoom in and show that a bit closer. So if we go in here, you can see this is the serial console settings for my particular device here. So the serial port is COM4, that's my adapter. Obviously that can vary based on your device. And the baud rate on this particular device, as mine was out of the box, yours might be different, was 115-200 baud. So all we need to do is hit open. That'll pull up a serial console window, which we can pull in and take a look at it. And now, let's power the device on. So we'll flick the switch on the back. Lights come on, fan starts spinning up. It beeps. You'll then hear a very slight little pip sound from it, and it starts up. So you can see there's a BIOS screen that's asked me to enter setup, and then, as you'd expect, it goes to a message saying insert proper boot device because there's no boot device. So, yep, that's it working. So we'll quickly take a look at the BIOS. There's no reset button, so we'll just literally need to power it off and on again. That's easy enough to do. And then we'll press tab and go into the BIOS on this. So that's it there. Console clears, press tab, and here we have BIOS setup. And I was actually quite surprised that it was in colour. I don't know why. I mean, serial consoles can send colour information, you know, it's just a standard serial terminal, but it's quite cool to actually get a colour console. And it is just a standard BIOS, just in serial console form. So you can come through here as standard. It's actually pretty comprehensive. There's various settings in here for things like adjusting fan speed, so you can put the fans onto PWM if you wanted. I'm not going to fit PWM fans, but if you needed this to be quiet, you could put PWM fans in and set various fan thresholds in here. There's the information on CPU temperature there, information about C states and SDIO, that'll be for the eMMC, USB configuration. Loads of settings in here, so it's not a super basic BIOS, you do actually have quite a bit of customization in here. There's not really much I would be really customizing in here, but there is options if you needed to. So I don't want to go through this too much, it's just a standard BIOS. But as you can see, if you come to the boot selection, you can see we do actually see the eMMC. So we have the built-in EFI shell and eMMC. So that's the eMMC chip. So that is present, so we can just install to that. So what we'll do is we now need to install PFSense. So just get out that BIOS setup, like that, and let's install PFSense. So obviously for this one, you need an installer drive. And with PFSense, you can pick whether you want a VGA console version or a serial console version when you download it. So I've explicitly downloaded the serial console version, so this will automatically try to boot using a serial console and not try and use a graphics card. If you're installing a different operating system, there'll be some way to do it on a serial console, maybe not Windows, but if you're installing any sort of Linux or Unix OS, there'll be some way to install it on a serial console. You might just need to look up how you do it for your particular OS. You might need to make a sort of custom USB stick or whatever. But yep, we have PFSense 2.7 on this. And 2.7 is quite important, because when I got this, I first just went to quickly check it out. I didn't end up installing PFSense, but just wanted to make sure it at least booted it. So I downloaded PFSense, the most recent version, 2.6, booted it, and none of these Intel NICs showed up. The two 10 gig ones did, but none of the Gigabit ones, and I panicked. So I did a bit of Googling, and saw people saying that, yep, 2.6 has too old a kernel version, but if you download the beta of 2.7, then that'll be fine and that'll support it. So I did, and it worked. Then I was thinking, I need to do this video on this device, I don't want to be saying, right, you can do it, but you need to install a beta version of PFSense. I wonder when PFSense 2.7 comes out. Turns out PFSense 2.7 came out the day that this arrived, so I literally had to wait a few hours for them to launch it that day, and then it worked. So this has the release of the brand new PFSense 2.7 on it, and that supports all the network interfaces in this. So, in theory, if we zoom in closer to the screen and press any key, we should be able to boot into PFSense installer and install PFSense on this. So there we are. Hit that. In case it's not doing that, I'll just need to probably power it off and on again. I wasn't sure if it would actually pick up the USB stick from there. Evidently not. So we'll just turn it on again at the back. And in theory, we should be able to install PFSense. There we go. So that's the PFSense bootloader, and that should now boot up. Okay, so this is something you're not going to see on normal PFSense. This is for setting up serial console, so it's what type of console, VT100 is default, I'll just leave that, that's fine. And we get this text user interface, so agree to that. Of course you can drop to a shell, but we'll just install PFSense. I'll go with ZFS, that seems to be the default now. Seems a bit over the top for firewall, but I suppose it's potentially better for things like power loss or, you know, data corruption. And realistically with 8 gigs of RAM in a PFSense box, I can definitely spare some of that for ZFS. I'll just stick with the standard configuration. It's a very basic setup, no redundancy, but it's nice. It's nice actually. You do have built-in ZFS support in the PFSense installer now, so you could have software RAID, which is good. So we'll just install to the eMMC drive. Oh, so you press space, and then press enter. That'll now ask me if I want to install it. So we're going to say yes, and that's now going to start partitioning the eMMC storage. And now, hopefully, that's it installing. Now, the one thing I've noticed is that I presume it's doing something right now, but there isn't any sort of disk activity LED on the front, nor was there one during the formatting and ZFS setup process. So I suspect that LED on the front is for disk activity, but it might only work with SATA SSDs, which kind of makes sense. So there isn't any sort of disk activity for that eMMC, which is a little bit annoying, but doesn't really matter. So yeah, that's now installing there. So we'll just let that install. I'll come back when it's done. And there we go, that was quick, so we'll hit reboot into the installed system, so we'll do that. It's going to shut down. There we go. And we'll pull out the flash drive. And in theory, that should now boot into PFSense. Also, if you hear that clicking is those bypass relays. When it turns on, you hear a click with the relays connecting the ports to the CPU or the network cards, and when you turn it off, you hear that click with it bridging the ports together. But yep, that's PFSense bootloader booted, and that's it booting into PFSense. So yep, that seems to have worked. So let's wait for this to boot. And there we go, so we're now in the sort of first time setup wizard for PFSense, so I'll run through this off camera, there's no point showing this, there'll be many better PFSense setup wizards. But what you can see here is it's actually identified all the NICs correctly, so we've got the 6 gigabit NICs and the 2 10 gig NICs, so that's really good. So we'll run through the setup process and we'll come back when it's done. And there we go, we're now booted into PFSense. So in theory, all I need to do is plug a network cable into this, I'll be able to get the web interface up. Okay, so let's try this. So I've set up the first network interface as the WAN and the second one is LAN. I'll need to reconfigure these later, but that'll do for now. So if we plug the laptop into the second port, that should be the LAN port. So it should in theory give the laptop an IP address. Connect it. So in theory, give that a little second to do its thing. 192.168.1.1 should be the PFSense box. Oh, there we go. Yep, there's obviously no SSL certificate. That's completely fine. And there we go. We have PFSense. Okay, so just gone away and just looked up. So it's apparently the default password is admin PFSense. If I spelled that right. Can we log in? There we go. So we're in PFSense, so we've now got a sort of initial setup wizard we can click through. By Netgate support, I'll just quickly go through all this and then we'll come back when we're at the main welcome screen. So here we are in PFSense. Now I'm not going to do a full PFSense tutorial, there's definitely much better people out there who've done much better videos of PFSense. I mean, I think Lawrence Systems and Crosstalk Solutions come to mind. But let's take a quick look at what we've got here. So as you can see, it's showing up fine. We're logged in, that's all working. If we go to the interfaces section, we can see that all of the interfaces show up, so all the gigabit interfaces and the two 10 gig interfaces show up, which is good. And obviously with these apparently being capable of 2.5 gig, but they weren't advertised 2.5 gig, you can see over here that it is linked at gigabit speeds, despite this laptop having a 2.5 gig NIC. So even though they are Intel i225s, they are only gigabit NICs, but that's fine. The two 10 gig uplinks are more than enough. But the other thing that's pretty nice to see is if you look over here, we have the CPU. So we've got obviously PFSense 2.7, but we have the CPU. But if you look at this, it's not what I ordered. The CPU I ordered was an Intel Atom C3558. However, this is a C3558R. And this is actually a really good thing. There's nothing wrong with a 3558, that's a perfectly good CPU. However, as I mentioned, it was launched back in 2017, although it is still a current model. However, the C3558R that I have here was launched in 2020, so it's a much newer CPU. And it seems to just be like an updated or a reconfigured version of the older CPU. It's just a little bit updated. So there's not a huge difference. However, as a 200 MHz higher clock speed, so the C3558 is 2.2 GHz, the R is 2.4 GHz, which as you can see that in the screenshot here as well. It also supports 2400 MHz RAM, whereas the older CPU only supported 2133 MHz RAM. And it also has 20 PCI Express lanes versus, I think, 16 or something on the older one. Should have remembered that. Yeah, the old one had 12 PCI Express lanes, so it's got more PCI Express lanes as well. Now, obviously I only ordered the 3558, so if you're buying one of these, you can't guarantee you're going to get the 3558R instead. But it is really nice to see that I did actually get a better CPU than I paid for. Not a huge difference, just a slightly updated revision. But it also goes to show that this is definitely using current gen parts, because that's a CPU from 2020. It's the latest Intel Atom C series available. So that's really good to see. Also, of course, because it's the modern CPU, it supports things like AES-NI, so it's got the encryption acceleration if you're running VPNs on this. Remember, there was drama back from my old one when I bought it because PFSense announced they were going to drop support for CPUs that didn't support AES-NI and then didn't seem to do that in the end. But yep, it supports AES-NI, it supports all the kind of stuff you'd need. As you can see down here, we have the eMMC storage. We're using 616 megabytes out of 5.2 gigabytes. That seems a pretty low formatting capacity, but I presume ZFS is doing some weird stuff with that. So yeah, plenty of free disk space for the operating system. There's enough space there for the operating system and putting all sorts of add-ons and features into PFSense. And if I did want to do any sort of traffic analysis that needed to write logs, I would pop an M.2 drive in just for that. But yep, that's PFSense installed, and it's working. So I suppose what's left to do now is for me to go away and do a bunch of performance tests on this. So I'll go away off camera, spend a couple of days doing some performance tests. Obviously I've not got the sort of equipment that professionals would have, but I can try and run iPerf over the 10 gig interface and see what it can do. And then we'll come back. And then after we've done that, we'll swap out those fans. And we're back. So I've now gone away, tested the performance a fair bit, so now we can talk about it. Now obviously bear in mind, I'll go through my test setup in a second. This is clearly a bit of a bodgy test setup, and I'm not an expert in testing this sort of thing. So if you're looking for more accurate performance figures, there's performance figures out there for the same sort of CPU and network interface, and realistically, there shouldn't be much difference between it being in this hardware or a machine from whatever other manufacturer. As long as it's the same CPU and network interfaces, it'll perform around about the same. So you should be able to find better performance tests for PFSense or VyOS or whatever other operating system you want running on this hardware. But we'll talk about what I found. So to quickly go through my sort of setup here, essentially what we have here is my old server down here running Bare Debian, and then this is connected with a standard SFP DAC cable into the firewall directly. The network card here is an old Chelseo, can't remember the model number, it's a 10 gig NIC that's bodgily installed here because it was a low profile card, so it's kind of bodged into the slot there. Obviously when I put a 10 gig NIC in this, I'll be getting a proper full height one that fits properly. Then for the other device I'm using, so you connect them to two different devices, I have this cable here. This runs over to my server in my rack off to the side. That also has a 10 gig onboard NIC, which is 10 gig base T, so that comes out here over this Cat6 cable into this switch here, which currently is acting as a very expensive media converter to convert this RJ45 to an SFP connection that can connect into this firewall. And if you're wondering, this switch is a Cisco Business 350 12XT, I think. I'll be doing a sort of fairly interesting video on this series of switches coming soon, so stand by for that. But yep, this switch currently is just acting as a very expensive media converter to let me connect the 10G base T from the server into this switch that supports SFP. So that's it there. And then all I really did was run iPerf between them. There's much sort of more proper ways to do this, using software like T-Rex to do proper packet generation with different sizes and generate like an internet mix of traffic. Unfortunately, I don't have a compatible network card to do that kind of thing, but if people are interested, I might do a video in the future where I get a proper network card and do proper packet generation and test hardware like this. But for now, I've just run iPerf. So first of all, what I did was connect both servers into the switch, completely ignoring the PFSense box, and run iPerf between them, just to check that both devices could reliably communicate at 10 gig. And with that, both devices with a single stream going in one direction could communicate at 9.4 gigabit a second, and with a full duplex stream I got 18.75 gigabits a second. Now bear in mind that iPerf only measures the contents of the packet, it doesn't include the headers in that data rate. The iPerf rating will always be slightly lower than the actual throughput that's going through the firewall. So at 9.4 gigabits in one direction, that's basically maxing out the 10 gig link. So that just demonstrates that these two servers can communicate at a full 10 gig, so they'll be able to fully test the potential of this firewall. So for the next test, I tested this for just bare routing performance. So I disabled the firewall in PFSense and put each server on a different interface on this server, on different subnets, and got the server to route between them without the firewall enabled. And with the stream only going in a single direction, again I got around 9.4 gigabits a second, meaning this could happily route 10 gigs without the firewall enabled. I then did a full duplex test where each server was sending data to the other one at the same time in opposite directions, and I got a total full duplex speed of 15.9 gigabits a second. So a little bit lower, but it's still happily able to route it well beyond 10 gig without the firewall enabled. Next up, I enabled the firewall and did the exact same test again, so I just had really the basic firewall rules and just allow the iPerf traffic through, not really many more rules than that. It's a very sort of stock PFSense setup. And with that, with a single stream, or with a full duplex stream, I was getting round about 6.5 gigabits a second. So with the firewall enabled, it's not firewalling a full 10 gig, but still, over 6 gigabits a second firewalling performance on such a low cost device is really quite good. As a final test, I wanted to test the NAT performance, so I put one server on the WAN side, one server on the LAN side, and tested between them. So with this, I was testing both the firewalling and the NAT performance. With that, I got a slightly mixed result, where uploading from the LAN to the WAN, so essentially almost like uploading to the internet, got a 6.5 gigabit speed, but downloading from the WAN to the LAN, so downloading from the server that was on the WAN side, got a speed of about 4.2 gigabits a second, so it seemed to vary based on the direction, presumably something to do with NAT or what firewall rules were in place, but still that's pretty respectable performance. You know, if you're needing to route a multi-gig internet connection, you've probably got more budget than one of these, but still, this thing seems to perform really well for this sort of thing. The other thing to bear in mind with these sorts of tests is I was using 4 streams, so I was using 4 threads of iPerf to do these tests. With a single stream, you're going to max out around about 2.5 gigabit a second, because obviously that sort of stuff is very much single threaded if you're processing a single stream. This has 4 cores, so if you have 4 streams, that will allow you to multi-thread that. But realistically, on for a lot of network traffic, if you're not really dealing with one big 10 gig stream, you're dealing with a lot of small streams that can be parallelized over multiple cores. And if you did need even more performance, there is always the 8-core version of this for only £80 more, which could be an option to look at. Also bear in mind that these figures came from using PFSense, which is more of a firewall that also supports routing. If you care about raw routing performance, you may be able to use something like VyOS or Netgate's Tensor operating system. Both of those potentially would allow even higher performance. Finally, I tested VPN performance. However, take these results with a massive pinch of salt, because all I did was I set up this server as a VPN client, this as a VPN server, and transfer data over that VPN from the server on the other end of this cable here. However, I have not tested to see what maximum VPN performance this server can get. So with these results, I don't know whether I was maxing out this server or this server. Because while this looks like a big impressive server, it's not. It's an old sort of Haswell generation Xeon E3. It's not a super powerful machine. So it may well be that with some of these results, I was actually maxing out this server and not this one. So treat these VPN results as like the minimum you'll be able to get, because this may be able to go higher, I'm just not sure. So I tested both OpenVPN and IPsec. OpenVPN was getting around about 500 megabits a second, which is pretty good. That would easily allow me to run my entire 300 meg internet connection over a VPN without issue. And with IPsec, once I enabled the appropriate hardware acceleration stuff in PFSense, I was able to get 900 megabits IPsec over this. And again, that very well may be this server that's limiting that and not this. So for VPN performance, it's pretty respectable as well. So yeah, that was sort of look at the performance there. Again, take these figures with a pinch of salt. If you want to get good proper performance results, look up proper tests of other devices that use the same CPU as this, and you'll probably be able to get a more accurate figure. However, the overall performance I measured was pretty good. Sure, it can't firewall at 10 gig, but it can easily route beyond that if you did need to do that without the firewall, and 6.5 gigabit through a firewall on such a low-cost device is really quite impressive. And as I mentioned, this is with PFSense. If you need to draw performance, there's other operating systems out there that might be even better performing than PFSense. The final thing to mention is the power consumption. So currently it's sitting as it was during that test video, where I have 2 SFP plus connections and 1 Gigabit RJ45 link. And with that, it kind of idles round about 21 to 22 watts, which is pretty good. Then during my testing, even maxing it out, transferring full 10 gigabit streams in different directions, fully maxing it out, it would spike up to maybe 25 watts. So power consumption, sure it's not as low as like a super embedded ARM type device, but it is still pretty good for a x86 machine with fans that are going to be drawing a reasonable amount of power. That is a pretty good power consumption figure. So now with all that out of the way, I suppose the final thing is to swap all the fans out in this with those nicer, higher quality ones. Okay, so before we change the fans, I thought I'd do some audio measurements just to see if the new fans are quieter or not. Now, I'm not changing the fans to make this quieter. Realistically, the current noise, while not silent, is absolutely fine because it would be stuck away in a little cupboard, comms cabinet in a cupboard, so the noise isn't a huge issue. But it's more just because the fans in this aren't the best quality, and I've already got some good quality fans spare, so I may as well put them in. But I thought I'd measure the sound levels just anyway, just out of interest. So, I'm not being scientific, I've not got a proper calibrated meter or anything, I've just got an app on my phone. But what we'll do is I'll be quiet, I'll just measure the background noise, then we'll turn this on, see what the noise is with the original fans, then we'll swap the new fans in and see how they compare. So let's do a test and see what the background noise is. Okay, so say we're in about 21 decibels or something there, so that's fair enough. So let's turn this on and see how it compares. Okay, that's all the fans on. Here are the, yep, rear fans are definitely spinning, so that's definitely running. So let's do another test now. Okay, so it looks like we're in about 36 decibels there or so. That seems about right. Definitely not that loud, but it is a very noticeable noise. So let's swap the new fans in and see how they compare. Okay, so now open up the device. So all we need to do is get these fans out. So as I demonstrated earlier, there's just these two screws on the back that we just need to undo, and that will remove the carrier that the fans are in, and then we can take the fans out. And obviously these are screwed in, but I'll be showing the new fans in a second, and I'll be mounting them on anti-vibration mounts just to reduce vibration even further, because the new fans do vibrate quite a bit. So get that out there. That's the fan sort of bracket now removed. Cables are just tucked under the motherboard. Pull that out, and there's our two very sort of generic, no-name fans that are both wired into a single connector. I've only got 2 pins, so there's no speed monitoring either. So it'd be nice to upgrade from this. So let's take a look at what we'll be upgrading to. And here we have the 2 new fans. So these are the fans I've gone for, which are Sunon maglev fans. Now, normally for a device like this, I would use Noctua A4X20 fans, which are basically 40mm, 20mm thick fans, basically the same dimensions as this, that are really good for network appliances like this. They're Noctua, they're very quiet, they're very efficient. They also do PWM versions. They're really good fans. However, they don't go up to a super high airflow level. Now, for this project, I wouldn't need that airflow. And in fact, this particular fan I have here, these particular, whatever that model number there is, are similar spec to that Noctua fan. However, I was needing these fans for a different project and needed ones that are higher power than the Noctuas. So I bought a bunch of different Sunon maglev fans, because they're only about a $5 each, just to sort of work out what airflow level I needed. So I used the higher airflow ones in that other project and had these just literally spare, so I thought I may as well use them. But they're actually very good quality fans. They're a bit cheaper than Noctua, about a $5 each. They're good quality, they've got sort of magnetic levitation bezel or bearing that's really quiet. They are really good fans, so I'll be putting these in. Now, the only thing that's a bit of a quirk with these fans is that when I ordered them from DigiKey, they turned up without connectors. I think they're designed to be more like a component in a project rather than a PC fan. So they didn't actually have connectors, so I had to crimp my own connectors on. Realistically, that wasn't too painful. It turns out these fan connectors are Molex KK connectors, they're called. Also available under different brands. These aren't Molex ones, these are JYK brand ones from Bitsbox, so it's a bit cheaper. So these are the connectors there that I had to crimp on. They're dead easy to do. You just get the housings, you separately order the terminal contacts themselves, like that there. And then you see the inexpensive crimp tool that I already had to crimp those on. So that was pretty easy. So yeah, it was a bit of a faff doing that, but ultimately meant these fans were only about £5 each rather than about £13–14 each for the Noxias. So these are the fans we'll be putting in. And as I mentioned, I wanted to mount them on anti-vibration mounts because while these fans are quite quiet, they do vibrate quite a bit. So I wanted to kind of anti-vibration mount them so they don't resonate in the case. So for that, I'll be using these anti-vibration rubber mounts here. These are Akasa brand ones. So these are quite good. So these will just slide through this plate here and we can mount the fans on. So I suppose the next step is to get these original fans out, get the new fans mounted on this bracket and get them back in the machine. Okay, so that's fans now mounted on the bracket there. Those mounts are pretty good, so they just basically pull through. They leave a sort of little nub on the outside that you won't even see because it'll be behind this grill because of this bracket. They then have a little sort of rubber part on the inside that keeps the fan from touching the back plate. They go through the fan and stick out the back. So they're on there fine, completely secure, they're not going anywhere, but they've got that bit of anti-vibration dampening, so that'll hopefully keep them a little bit quieter, so that'll be good. So, yep, that's fans on there. Cables coming out the back there into the connectors that I put on, and obviously I twisted these as well, just kind of keep them all in one go, because they were literally just bare wires. So now let's get this into the case, get these plugged in, and test them out. There we go, that's 2 new fans installed there. The cables come out, route under the motherboard, come around here, and just plug up into 2 connectors over here. So that's pretty neat. Anti-vibration mount should really help. I mean, I could actually cut these mounts off to not have these bits dangling around, but they're not really getting in the way of anything. And leaving them fully extended means I can easily replace the fans without having to replace these mounts, which is good. If I cut them off, I wouldn't be able to get them through new fans and I'd have to replace them. But yep, hopefully these new fans will be a lot more reliable. And also, because they're now wired into 2 separate headers and have the tachometer connection, I'll now actually be able to independently monitor the speed of both of these fans, whereas in the original fans there wasn't any sort of speed monitoring at all. So being able to actually monitor these is also quite good. I could probably set something up in PFSense to monitor the fan speed and alert if any of them failed. And even the one on the CPU also already has speed monitoring, so I can actually now monitor all the fans in this machine, which is quite good. So yep, that's them both replaced. So all I need to do is get it put back together and test the new fans out. So let's turn this on and see how it compares. So, take it on the back. That's new fans spun up. And yeah, they definitely sound quite a bit louder, so let's see how it compares on the sound meter. So yeah, around 41 decibels, 41.42 decibels or so. So they are a fair bit louder than the old fans. However, it's not really a problem because, as I've said, where I'm putting this, the noise really isn't going to be an issue. And it's going to sound stupid when I say it, but these fans sound better, which is a weird thing to say. But while these fans do make a noise, it's just, it sounds like a cheap fan. Whereas while the fans in here are also making a noise, it sounds more like a high quality or high end network switch because they're good quality fans. So yeah, sure, the fans are making a bit of noise, but it sounds more like a proper fan, not these, which are more like sort of grinding type noise. It just sounds like cheap sleeve bearing fans. And also, these new fans are moving an absolute ton more airflow. Now, I can't exactly test that, I've not got the equipment to test airflow, but just putting my hands behind the device, they are moving a lot more air. So you can feel a lot more air coming out the back, and also a lot more air going into either side of it. So even though the fans are a bit louder, they're also going to be cooling this a lot better. But for my use case, and given I already had the fans anyway, these fans seem to work absolutely great. And even though they're a little bit louder, I trust them much more to last for a long time. Whereas these fans, I wouldn't be surprised they died after a year or so. Whereas these ones should be good for many, many years of full-time use. So yep, that's fans now replaced. So there you go. That was a look at this cheap 1U server from AliExpress. And for the price, you get a lot for your money. Getting a current generation Intel SoC with 4 cores, low power consumption, and 2 Intel 10GB NICs that run directly off of that SoC is really good value. It certainly makes this a much better option than many of the other machines on there that use older CPUs or have separate 10GB NICs that are running off of separate chips on the PCI Express bus. With this, you're getting really good quality Intel NICs, a good Intel chip, 8GB of eMMC on board is ideal for installing things like PFSense without a separate SSD, and yeah, overall, I really like the hardware. So yeah, it's been a really fun project coming back to these sorts of weird AliExpress machines 5 years after I last looked at this one, and it's really interesting to see how they've come on. And yep, these are definitely very viable options if you want to build a low-cost PFSense box. So yeah, thank you very much for watching. If you're interested in buying one of these, I've put links in the video description and in a pinned comment, and also stand by for future videos where I'm sure you'll be seeing more of this thing.